One more example for pooled t-test. It has two groups again. Sample number 1, sample number 2. Okay? Please read this example. I want to introduce you what is the double-blind experiment. It's most of the time in the medical field, we can apply the double-blind experiment. For example, when we make the new medicines, usually we apply to small animals, rats, then rabbits, pig, monkeys. We had a good output. Finally, we should apply to human bodies. But we have to be careful. So usually, if a company made a new medicines and give to the doctors, and the doctors suggest the patients, if you want to take the new medicines, if you want to participate in this experiment. In that case, the company, the pharmaceutical company, didn't say which one is the true medicines. You know, always we give doctors the other one. It's a fake one. We call this one is a placebo. Have you ever heard of placebo? You know, the placebo is nothing. It is not a new one. So always we give doctors placebo and the new medicines. Doctors, they don't know which one is a placebo and which one is the new medicines. Even the doctors give the prescriptions to the patients. Absolutely, patients, they don't know which one they are taking. So double blind means doctors, patients, they are blind. They don't know anything. Only the researchers, only the company, they knew which one they gave them. That is a double blind experiment. Because, you know, even though we gave placebo to the patients might get better. It might get better, right? So because of that, sometimes we apply the double-blind experiment. Okay, so in this case, we had two samples. One is the fortified, and the other one is another one, right? And here's the mean difference, sample, standard deviations, and sample size. Okay, apply the 6 steps. As I told you, always in the null, it's a mu1 is equal to mu2. Alternative 1, 3 choices. 1, 2. So what is inequalities? Not equal to, greater than, less than, which one? It is a claim. And here's a more, right? Then do you think is mu1 is greater than mu2? Or mu1 is less than mu2? Let me give you another tip. Sample mean number 1 was 9. Sample mean number 2 is at 1.6. Which one is bigger? 1 is bigger. Yes, mu1 is bigger than mu2. We just follow the inequalities. Even 9.0, 1.6 were the sample means. But the mu1 and mu2, they are the population means. But it's the same. It is the same thing. So at least it is not two-tailed, not equal to, then you just plug into the two sample means. It just follow the directions. Next, alpha. Can you see the significance level? 5%. Then now, let me take SP. N1, 14 minus 1. S1, 37.4 square. $12 minus 1. $34.6 square. $14, 12 minus 2. Please give me SP. As I told you, please take separately numerator, denominator, and then take the ratio, and then take the square root. Anybody who took the SP? 36.14. 36.14. Okay, let me keep going. It is not a test statistic. Take the mean difference, 9.0 minus 1.6 divided by 36.14, 1 over 14, 1 over 12. 0.52. The test statistic is 0.5 and 2. Now, we need a p-value. Step 4, p-value from t-table. How many degrees of freedom? 24. 14, 12, minus 4. 24. Please go to the line. Please go to the degree of freedom. 24. In the line 24, who is the smallest t-score? I expect in the first column, there is a smallest t-score, right? How much is this? 1 point something. In the line, the degree of freedom 24, the smallest t-score is a 1 point something. Then where is our test statistic? 0.52. It's before the 1 point something, the before smaller than the smallest t-score in the line, right? So we can expect the p-value is up there. See, here's a t-table, and here is a 24 degree of freedom, and we had t-score 0.5 and 6. I mean here, it's less than 1.318. So now we can expect our p-value is up there. And in the first column, there is a probability 0.10, 10%. But we can expect our p-value is here, up here. And here is the 10%. How do you think? Is it bigger than 10% or less than 10%? When you look at the probabilities is up there, in this way, it's getting bigger. To the right, it's getting smaller. So we can expect the p-value is bigger than 10%. Does it make sense? Right? So let me go back to the problem. Now I can say the p-value is bigger than 10%. Oh, just a second. Should I take twice? Why not?
It's not two-tailed.
Because it was not two-tailed. It was a right tail. See? We took positive, even though it is very small, but we took positive test statistic, right tail, without twice. How much was alpha? Alpha was 5%. Is it bigger than 5% or less than 5%? Absolutely, it's bigger than 5%. Even bigger than 10%. Decision. Do not reject the null hypothesis. What should I do? Do not reject the null hypothesis. We should not say that, but accept the null, right? Yeah. Take the null. Please don't say accept the null, but it's actually the decision must be not reject the null. That means we have to interpret the null statement. What it said? They are same. Who are same? What was that? What was it for? Oh yeah, I'm sorry. Here's the claim, right? Yeah. We had the average of the fortified and odd fortified, the reduced, the PTH level is more or less. What is the interpretation? They are same. So we have to interpret at the end, step 5, whatever, they are same. But you should understand who are they, right? But simply I can state the conclusion, they are same.
So on the whole test, you don't, even if it's not spot, you don't have to subtract it by 1?
No.
Only on the Z-score?
No, always, yes, it was only for the z-test, because look at this. The t-table gave us only the right tail. Please look at the picture, the small picture on the top. T-table gave us only the right tail. So before we took negative test statistic, we needed right tail, but we ignored the sign. So we take the probability from the t-table. Actually, it was the right tail, but we needed left tail. But the t distribution is symmetrical, right? And now here we had positive test statistic. Exactly, we need the right tail probability, and the t-table gave us the right one. But in the z-table, z-table gave us only left tail. So sometimes, what times? When we took positive z-score as a test statistic for the right tail, then we need the right tail probability, but the z-table gave us the left tail, so we did 1 minus. So in that case, in the z-test, sometimes we did 1 minus the left tail to get the right tail, but the t-table always give us the right tail. So 1 minus, the role of the 1 minus, we did ignore the sign. We took the negative t-score, then just ignore the sign to take the positive t-score. Yeah, that is the same thing. That is a good question. Thank you.